So hi everybody and welcome back to our C++ Thursdays for absolute beginners. This video 319, and in this video we continue with our exercise. We stopped here at number 13, and you should like all time read the question, answer as good as you can, compare it with my answers or better with online resources, good C++ books. And yeah, with that said, we start. And again, like all time, you read the question, pause the you pause the video. I will not pause the video. I go straight to the answers. And yeah, here on number 13, you can see we have here the number 42. Then we have a Boolean value true and a null pointer. And you should. What are this called? First of all, what is the technical term? So there's a name for those. And then the value category. And then make a little example of that. So you pause the video, I jump to the answer, and here is that. First of all, these are literals. So you can see there are different kind of literals, numbers, can, Boolean value, the null pointer. But here is something very important that you keep in mind. We also talked about string literals, and string literals are not R values, because this kind of stuff are R values. They are not R values. What was the reason for that again? Why they are not R values, the string literals? And the reason was they are safe. What was a string literal? A string literal is, for example, like this. Hello world. This is a string literal. This will be saved while the program is active, and that's why they are not considered as R values. This kind of stuff, what we have here on the other side, these numbers which you just create right now, use it, and then the compiler discard this value. They are called R values. Okay, here are little examples, and careful about these examples what I made here. I hope you have better ones. What is the problem here? When you read the whole thing, this one is an L value, because this is the whole expression. When we talk about R values, I'm talking just about this side here, this number 42 here. But when I bind it to a name, then the whole expression here is an L value. Careful about this, and the same goes for that one. And here we have a null pointer. For example, we can create a pointer, we know this. And in contrast to references, we can set a pointer to a null pointer, a reference we can't. And yeah, then there is also, when you go a little bit advanced and try to see how this kind of stuff is implemented, careful about this. The implementation can, I see on the web, can lead to confusion, because you would think the implementation is more like an L value, but then you have read the official documentation, which means the official C++ paper, and they are explicitly noted as R values there. All right, that's enough for that. Let's continue a little bit. The next question is 14. So, and here it says a function call or an overloaded operator expression whose return type is non-reference, such as point. You make some examples of this one here, and we already talked about this one. If you remember, something similar we had. The only difference was this part here. It was, instead of non-reference, we had an reference type, if you remember that. And now you should again pause the video, try to answer as good as you can, and I jump again to the answer. The answer here is, first of all, it's an R value, because non-reference types, what we talked in our other example was with L value reference types, and L value reference types convert the whole function call to a L value, and here not. And here is this example what I made here. I hope you have a better one. So the important part here is just this part here, and here is something wrong. What is wrong here with my example? Can you see it? What you see here is just a declaration and a definition, right? But this one here says call. So this one here is not the right example. This one I needed to make the example now. For example, now I call this my function to call, and then let's give it number 5, something like that. You can see this here is actually a function call, and whose return type is a non-reference. So careful about that you not say this one is here, this one, the call here is important. All right, with that said, we can go to the next part. Let's go to 15. And in 15, we have here this here, A++ and A-. We already talked about those. Yes, we talked, but careful. Why I say careful? Because we have not talked actually about those here. We talked about something similar. And then what is the difference? Yeah, you have to find now the difference, value category like all time, and make a code example. So I jump again to the answer. You pause the video, and here number 15. First of all, also what they are called, right? Also these are post increments. Have I made here the name for them as well? That's not so important. Is here they are post increments and post decrements. We are talked not about this here. We are talk something similar where the plus and the minus were in front, and they were the pre increment and the pre decrement. The value category is here R value. The other one which we talked was L value. And then I explained to you why this was an L value, and now the question is why these are the R value. I mean, we just changed here the position, right? The other one, the L value, was in front. Now they are behind, and the question is why they are R values and not L values like the other ones. And here I have made here a code example for that to explain this a little bit better. First of all, I declare a variable A and assign it the number 5, and I declare a variable B and assign it a number 5. Then I say, okay, this B here I take and say, okay, I want that you get the A here assigned. So I assign to this B here this A, but I use this increment, right? But this post increment now. So the question is now, what is the output of that? What do you think? I hope you know it. It is B is 5. So we get an output. Let's write it here. Let's write it. So output like 5. I hope that everybody is okay with that. But the question is now, okay, we have nothing changed here. Why we use that? For what is this A++ now here? The answer is this one did something. The only problem is it has not changed B here at this point, but it changed something. And it changed the value of A after it assigns first the value A here to B, and then it incremented A. Also, let's get it right. First, we have here B. I want to assign the value of A to it, but at the same time, I'm incrementing it. So you should not confuse, because it's a post increment. It says, I will take first the number of 5, I assign it to B. So that's why we have the output of 5. But then afterwards, I increment the value of A. This will be 6 later. So when I go here and would put out stdac out A, now the output would be what? Yes, 6. Because that's the reason, and this is a little bit this is the reason why sometimes this one is confusing. But remember, when you see a post increment or pre-increment, remember that you can always write this one not in the short form as well. You could always write something like that. B plus B plus, no, you can write it E and then increment it afterwards as well. But this is longer. You would write something like so. I don't know, something like that, and then go on. But this takes too much time, so you see they try to make this all faster in one line and yeah, shorter, but it's not too difficult. So important here is the value again, which is used here. The value is again temporarily after the assignment. So first of all, like I said, they take 5 here from A, but then they change this A++ is changing again the value to 6, and the 6 here at this point is assigned to nothing. Right now not, later yes, when the compiler goes on, but right, that's why it's an R value. Again, we know R value means all time. It's a temporal value which is not bound to anything at this point. At this point here, after the increment, it is not bound. It will bound. It will assign the new value to A later, but at this point not. Okay, I think that's enough for now. Should we go on? I think I have this. I think that's enough for this video. So if you have any questions like all time, write in the comment section, and see you in the next video. We will continue a little bit more about this value categories, and have a good day. And like all time, never give up. Bye.